Hello everybody, tonight we're gonna talk about correlations, and this video is gonna show you how you can compute correlations in SPSS. In class we're gonna talk about two types of correlations. We're gonna talk about Pearson correlation and we're gonna talk about Pearson correlation. And I'm gonna show you how you can compute those in SPSS. So the first thing that we need to do is when we're computing correlations, we want to make sure that the variables we want to use are interval or ratio, and there's some kind of variability across scores. So if we have one variable that it's a constant, that for example here in this data set, if we have fear of asking for help only once across all participants, we will not be able to use that variable in any type of correlation analysis. We want to make sure that there's some kind of variability across scores, because those differences is what drives the computation for correlations. So just a quick look, we can see that the scores vary across participants. So that is a good sign that all of these variables will be good candidates to use in a correlation. So whenever we do correlation in SPSS, we can take variables in pairs and compute a single correlation, or we can do multiple variables and compute multiple correlations at a time. But let's take it one step at a time. So let's say that we want to compute and see if there's any correlation between the test class anxiety and interpretation anxiety. So to do that, we're gonna go under Analyze, Correlate by Variate. I'm gonna go ahead and reset that. So we said we want one of our variables to be the test class anxiety, so we're gonna select it and we're gonna move it to the right under the variable list. We're going to take the next one, interpretation anxiety, and also move it to the right under the variable list. If you would like, you can click on options and you can ask for the means and standard deviation of those. But we don't have to worry about that for now. So we have a Pearson correlation that assumes normally distributed variables. In this case, we're going to assume that these two variables are normally distributed. In the real world, what we have to do is test for that normality and make sure that that normality condition is met before we can run Pearson correlation. If that normality condition is violated, we have to go different route. So the next thing we have to do is just click OK, and SPSS is going to give us our correlation table. So here we can see the two variables. It's a matrix, which is pretty much a mirror image. If you guys draw a line diagonally, your view on the bottom left is a mirror image of the top right. So what we have is that test class anxiety is correlated with interpretation anxiety. Remember, the first thing to do is look if our correlation is significant. So we look at the two asterisks that shows us that our correlation is significant in the 0.01 level. Now that we know that it's significant, we can make comments about the direction and the magnitude of the correlation. So in this case, we're going to have a significant, positive, and I would say pretty strong correlation between those two variables. If you take it a step further, since it's just a significant correlation, we can say that about 36% of the variability in our test anxiety variable is explained by the interpretation anxiety, and vice versa. We have 36% of variability in the interpretation anxiety that could be explained by the test class anxiety. So this is how we do the correlation whenever we have two variables. Now, if we want to look at multiple variables at a time, we're going to go the same route, and we're going to look at actually the correlation matrix that SPSS gives us. So if we go to analyze correlating bivariate, let's say to the first two correlations that we were looking at, or the first correlation with the two variables that we looked at, we want to add the fear of asking for help and worth of statistics. Again, the assumption is that all of these four variables are normally distributed. We're going to click OK. And here's our matrix. So as you see, again, we have a mirror image. The bottom left, it's a mirror image of the top right. So we don't have to interpret all of this because they're just the same correlation. Whether we say that the test anxiety correlates with interpretation anxiety is the same as saying that interpretation anxiety correlates with the test anxiety. These are two-way connections or relationships, so it doesn't matter which variable comes first. So if we look at the test anxiety, we can see that SPSS gives us all of the correlations across the other variables. So we look the interpretation anxiety, which we already looked at. The fear of asking for help, the correlation is not significant, and the correlation between test anxiety and worth of statistics is significant. And you can see in some cases you're going to have a single asterisk which tells you that the correlation is significant in the 0.5 level. The double asterisk on the other side gives you that the correlation is significant at the 0.01 level. So whenever you're running multiple variables, you can have correlations that are significant at different levels. Now if we look across, now the interpretation anxiety, we can correlate with the fear of asking for help, which we see a negative correlation, but since it's not significant, we can assume that this correlation is the same as 0, and actually the magnitude, if we look at it, it's pretty close to 0, and the interpretation anxiety is positively, I would say moderately and significantly correlated with the worth of statistics. And we can go down and look at all of the variables and compare across all correlations. So let's say that we don't have normally distributed variables. One of the ways we can address that is, instead of Pearson correlation, to conduct Spearman correlation. And the way to do that is if we go under Analyze, Correlate bivariate, we're going to use the same path. Let's go ahead and reset that. And I'm going to choose just the first two variables. And here, instead of Pearson, I'm going to click on the Spearman, because this is the one that I want to use if I know my variables are not normally distributed, or if I know that there's some kind of rank ordered variable. So again, we can ask for, actually SPSS doesn't even give us that option. So let's go ahead and click OK. And here it is. And the Spearman raw, or the Spearman correlation, is still significant and at the 0.01 level. But now if you see, the value of that correlation is a little bit different than the Pearson correlation. And the reason for that is because we are looking at the rank of that data rather than looking at the magnitude of differences or the variations across all the participants. So just as a side note, but these are the two ways that we can compute correlations in SPSS. And SPSS gives us a nice and clear view of what that correlation is, and even specifies for us whether the correlation or correlations are significant given the data that we have.